So, hello everyone. Today I'm going to explain the steps I took to improve the performance of my classifier and how I assess and enhance its fit. So to start, I focus on thorough data pre-processing. I clean the data by handling missing values, removing outliers, and converting categorical variables into numerical from via one-hot encoding. I also scaled numerical features using standard scaling. These steps ensure that the data fed into the model was of high quality and that the different features were on a comparable scale. One major challenge was class imbalance, as the minority class was underrepresented. I addressed this issue by applying SMART, which synthesized new samples for the minority class, thereby balancing the dataset. This allows the classifier to learn more effectively from both classes and reduce the bias toward the majority class. After pre-processing, I experimented with multiple classification algorithms. I trained several models, including random forest, gradient boosting, ADA boost, XG boost, light GBM, as well as logistic regression, KN decision tree, SVM, Gaussian naive Bayes, and extra trees. For each model, I evaluated the F1 score on the training set to choose the best performance. The F1 score was my primary metric because it balances precision and recall, which is especially important to imbalance the datasets. Once I selected the best model, I further assessed its performance using cross-validation. I employed five-fold cross-validation to estimate the model's generalization performance more reliably and to mitigate the risk of overfitting. So to better understand how the model was fitting the data, I plotted the learning curves. The learning curve allowed me to see how the training and validation F1 scores change as the training sample size increased. This step was crucial for diagnosing whether the model was overfitting or underfitting, and it guided me in fine-tuning the model's complexity. Additionally, I plotted the precision recall curve, which is particularly useful when dealing with imbalanced datasets. This curve shows me the trade-off between precision and recall across different threshold settings. And I computed the area under the precision recall curve as a quantitative measure of model performance. Lastly, I examined the feature importance from the best performing model. This analysis helped me identify which features contributed most to the predictions and inform decisions on whether to engineer on remove certain features to further boost model performance. So in summary, my approach consists of rigorous data cleaning and pre-processing, including handling missing data, scaling, and one-hot encoding. And also, I use SMART to address class imbalance. Next, also experiment with multiple classifiers and selecting the best one based on F1 score. And I also assess model generalization using cross-validation, diagnose the model fit with learning curves and the precision recall curves. The last one is evaluate feature importance to ensure that the model was learning from the most relevant data. So these steps not only improve the classifier's performance, but also ensure that the model was well fitted and could generalize to new data. So thank you for your listening. I'm happy to answer any questions.